guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. Now let me show you an example of Hess's law. So let me go over this diagram really quickly. It's the same as the one I showed before, but basically simplified. So if you go from A to D, there's a change in the enthalpy value for that. But since the enthalpy changes are additive, which is Hess's law, if you know the delta H for A to B, and also for B to C, and then finally for C to D, you can take this roundabout route to obtain this value. And all you would do is do delta H1 plus delta H2 plus delta H3 to get the A to D reaction. So now let me give you an actual number example. So if we start out with nitrogen gas and oxygen gas, and we end up with 2 nitrous oxide, NO, the delta H of this reaction is given as 180 kilojoules. So remember, these are all in units of kilojoules or joules because it's units of energy. So then we have another reaction that is 2NO plus O2 going to 2NO2. The delta H of the second reaction is negative 112 kilojoules. So now, if someone asked us, what if we wanted to start out with N2 plus O2 and end up with NO2? You don't have the answer to that by looking at the first equation because you start out with the right reactants, but you end up with NO instead of NO2. And if we look at the second one, you also can't get that direct reaction because you have NO and O2 and end up with NO2. So how can you get this particular reaction? Well, the answer is very easy. All you have to do in this scenario is add these two reactions together. So when you add it, you end up with a net reaction that looks like this. So we have N2 plus 2O2 plus 2NO goes to 2NO plus 2NO2. Now when something's on both sides of an equation, you can actually cancel it out because in this case you're saying you're putting in 2NO, but you're getting out 2NO right here. And so let's cancel these out. And what's your net equation? N2 plus O2 gives you NO2. Awesome. So then the enthalpy net is just going to be the addition. So delta H1 plus delta H2. 180 plus negative 112 gives you 68 kilojoules. So yay, we finished this Hess law problem. And so this value is a positive value, which means that this is an endothermic reaction, meaning that heat had to be supplied in order for it to happen. So another way in which we can calculate enthalpies of the reaction is by using bond enthalpies.